So recently I made a video on writing a bloom shader, a bloom effect in GameMaker, and I mentioned in that video that bloom is kind of a heavy effect. We did do one major optimization in that video, taking the form of like doing our blur in a separate horizontal and vertical path so that you don't have to do a huge double for loop in the shader. But I can't remember exactly what I was doing. I was reading someone talking about something else, some other post-processing effect, and they brought up something else that you can do to optimize bloom. And this is something that you can do not only in a bloom shader, but also in a lot of other post-processing effects, like a glow or a blur or something like that. Something that is, like by nature, is going to smear out pixels across each other. And that is that you can actually compute a lot of these effects at a lower resolution than the full image. And doing that can actually save quite a bit of performance time. So I'm running this on my old computer, which contains a somewhat smaller GPU than the one that I've been using for the past couple of months. And we're going to hopefully be using this to see a bit of a more pronounced issue, see a bit of a more pronounced effect when it comes to the performance of a bloom shader and things that we can do to speed it up. So I've also gone and uncapped the frame rate so we can see exactly like how fast we can spit out images using this bloom shader on my GTX 1060. And we're going to be seeing how different things that we do have an effect on exactly how expensive this is. So at minimum, just doing bloom on this image and doing nothing else, we can get about 1,000 FPS or so. This takes about a millisecond to compute. If I turn it all the way off, do minimal bloom, we can about double that, and we're gonna see how much we can bump that up by computing the bloom at a lower resolution than the full image. Also, to make the effect a little more pronounced, I did bump up the window size to 1600 by 900 from 1366 768, just so that we can do this on a bit of a bigger image and make this a little bit more expensive on purpose. So the first thing I'm going to do is everywhere where I have gone and like hard-coded dimensions to be window get width and window get height, I am going to separate those out into a set of local variables, and our W, W, and HH we can call them. And I'm going to get back to those in a minute, but first, let me just go find and replace all occurrences of W, W, HH in this code, so we can use those width and height variables when it comes to like drawing things to the correct size, other than like instead of going straight to window get width, window get height. And that's so that we can go and mess around with this later. By the way, I am going to obviously be talking through this video assuming that everyone's seen the previous one, or at least knowing what the bloom effect does and why we're using 3 different surfaces here as intermediate stages of doing this effect. Where were we? So the other thing I'm going to want to do is I'm going to want to, anywhere where we like draw a sprite stretched or draw a surface or whatever, I'm going to want to make sure that, so the brightness surface, whether this is coming from the application surface or whether you're like drawing your test sprite onto it, we're going to want to make sure that that is being drawn with the dimensions of W, 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 and HH. The intermediate surfaces, I'm also going to want to draw surface stretched, W, W, HH. These should be the same size, because we're like doing that up here, but just in case. Let's see, this other intermediate surface down here. So both the horizontal and vertical blur. And also at the bottom, when we say draw sprite stretched, our flower sprite for the second time. Again, this probably would be like the application surface or something. We're going to want to draw that stretch to not WWHH, but we're going to want to make that the size of the window again. Because we do now want this to fill the full screen. This should probably be in post-draw and not draw GUI, shouldn't it? Anyway, we want to draw our original image to fill the full screen, and we're also going to want to draw surface stretched, the final blur surface to fill the entire screen like this, because if we downscale it a little bit, we'll want to scale it back up when it comes to doing the final image. Let's see, we'll also want, because I am going to set this up so that we can like resize the surface on the fly later on, but I am going to go ahead now and say if surface get width, surface brightness is not equal to WW, or surface get height surface brightness is not equal to HH, then we are going to surface resize. And we are going to, we're going to resize the surface if it's not the correct dimensions, and we'll do the same thing with both our horizontal and vertical blur surfaces as well. And, alright, that's all the boring setup. So, if I wanted to compute bloom at half resolution, I could say WW equals window get width times 0.5, HH equals window get height times 0.5. And this will do it. This will give us something that looks more or less like the bloom effect that we had before. You will notice some slight differences, and I will get to that in a minute. I will run some image diffs on the before and after. But we can, right off the bat, see that with the bloom cranked all the way up, our FPS has doubled from what it was before, from about 1,000 to almost 2,000. And if I were to reduce the bloom size when we do this, we're going to see that our maximum FPS is also going to go up considerably because we're running this on a lower resolution surface. We have fewer pixels to process. Let's see. I do want to let the user in this test situation dynamically control exactly how much of a reduction we are. So this is half on each axis. So that'll be a total of 1/4 the number of pixels that we're having to do bloom on. And if I were to go define in my my create event a new bloom scale or something like that, we could initialize that to 1. We could make ourselves a new variable definition that's going to be like a bloom scale, which is going to be a slider that goes from 0 to 1. And again, debug overlays are really cool. They're probably one of my favorite recent additions in GameMaker. Instead of you know what? I will actually want this to be a minimum of like 0.1 or something, because if you set it to 0, it's kind of going to break. But let's go ahead and multiply window get width, window get height by bloom size. And again, this is going to have some visual implications, which I'll address later. But now, just look at the invalid surface dimensions. What did you not like about that? Did I not? Oh, I need bloom scale. I was multiplying it by the wrong value. It should be width and height times bloom scale, not bloom size, because size is like the radius. Alright. Let's dial this all the way up. Let's play with this bloom scale slider a little bit. And again, you can see that there is a visual difference. We will clean that up later. But as I scale down the output surfaces, now even with the bloom cranked all the way up to maximum, if you set the scale of the computed bloom to be like 1/10 on each axis or 1/100th the total number of pixels, our FPS has gone up from about 1,000 to 2,600 or so, 2,700 or so. And of course, if you reduce the bloom size and make that a little bit less intense, we can increase that a little further. Alright, so that's pretty fun, but we do have the difference. Oh, I wanted to hang on. I did want to do like a before and after. So this is how it was by default at the end of the last video with bloom cranked all the way up. Let me go and alt print screen that and paste that into Photoshop. And when we're done with that, we can bring this all the way down, and I can alt print screen again and bring that into Photoshop. And just by like toggling this on and off, we can see there's a difference. Obviously, you could see that by when I was messing with the slider. But we can also throw a difference blend mode on the first one, and we're going to basically get an image diff, and we can see all the exact regions, like how and where like the glow has been changed. And the reason for this, actually, you know what? Should I make you all guess why this is happening? Alright, you've all got 10 seconds to look at this before and after and see and try and guess, if you don't already know, why you see the difference here when you shrink the bloom size. And then we'll proceed and fix it. So, alright, let me know what your guess was in the comments. The problem here is that we're gonna need to change something else down here in the farther down in the process. So when you do the like the blur effect, the horizontal and vertical blur effect on the brightness cutoff in the blurring stage of the effect, we are looking at a bloom size in like pixels, or I guess texels if you prefer, and that would work out as you expect when the size of the bloom surface is 1-to-1 with the original image. So like if you tell it to do like a blur with a radius of like 10 or something like that, you would get a blur with a radius of 10. But if you scale that down, those pixels are going to be blown up quite a bit, and suddenly a blur with a radius of 10 is going to turn into a blur with a radius of 100, which is definitely a little bit more than we bargained for. So we're also going to want to multiply the bloom size by the scale, so that like if you scale it down by half or whatever, or a tenth, your blur radius isn't going to be like proportionally blown up, which definitely looks a little bit weird. So now let's dial this all the way up. Let's play with the bloom scale, and we can see that as I move this up and down, we can see a little bit of jitter, and that's because as I zoom it in and out, like exactly where the individual pixels fall are sort of changing around, moving around. But overall, like, well, I won't say it looks the same. It looks pretty similar to how it did when it was at full size, especially if you just drop the size of the bloom surfaces by half. It looks pretty similar. When you start to really decimate it to like a tenth, 20%, it starts to go a little wild. If I were to go and do an image diff at like 60%, let me go back to Photoshop. Let me get rid of these two layers. Go away. And we can, that's going to be our reduced copy. And if I bring that back up to 100%, this is going to be our original copy. Throw the difference blend mode on it. And we can see that the differences, you can still see it, especially if you zoom in. Basically, the lighter areas in the image diff are where there is a bigger change between the original and the modified image. But it's definitely, it's not bad. And for the performance increase that you get, something like a bloom scale like this is definitely something that might be worth exposing to the user. I actually want to do some tests with like the built-in GameMaker filter effect. Like there's a couple of filter effects like this that are notoriously expensive, and I'm considering doing some tests and making a feature request to GameMaker to like add a scale option like this to make it a little bit less expensive. Anyway, so there's one other thing, and am I doing it now? I don't remember if I've already done this, but it makes a little bit of a difference when you sample from surfaces in post-processing passes like this, but it makes a little bit more when you're scaling them up and down. GPU set text filter. So turning on or off texture filtering for something like this might or might not be desirable. I'm going to say in most cases it might be. It probably will be desirable because it will smooth out like it'll smooth out edges a little bit more. I don't think I'm doing this anywhere in this project. Alright, so I haven't gotten it set, and oh, I do have it set in game settings. Alright, anyway, so that's fine. But I do want to add another, like, let me make another debug checkbox, because I do want to show what this looks like. So we'll just make a little checkbox in the debug menu, toggle that on or off, and then in the beginning of Draw GUI, we'll be able to set the texture filtering setting to whatever that value was, so that we can see what the difference is. It's probably, when I turn it off at full resolution, you can see a little bit of like crunchiness, especially on like the chicken wire in the background over there. But it's for the most part, for the smoother edges in the foreground, you don't really see it. But you're going to see it a lot more if I bring the bloom scale all the way down. You can sort of see like blockiness. It almost looks like macro blocking in like a low bitrate video or like a JPEG with a high compression ratio. When I turn off texture filtering for these effects, and yeah, when this is running at full resolution, the difference is a lot more to do with the fact that like the original image is being scaled down to fit in the window than it does have to do with the post-processing effect. But when you start to scale the bloom, when you start to size the bloom scale down, you definitely start to see it a little bit more. All right, so I think that's gonna be it. We can see how this looks on some of the other pictures, I guess. I remember being a fan of the bloom effect on the Spirea here. See what does this look like when I bring it down to like 30%? All right, that's still not bad. I would accept that if it like doubled my frame rate in a game. So yeah, that's another fun optimization you can do with post-processing effects like this. I think I'm gonna stop here. If you want the code for this, I guess I might as well. I'll throw this on another branch on the Bloom tutorial repository. Oh, create new branch, huh? If you want the code for this, look for the GitHub repository down in the description of the video. Otherwise, my name is Michael. I like wizards and dragons and making games. I like to post videos on weird stuff you can do in GameMaker, so if anything like this appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. You should all go check out Wizarducks and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to the Steam page can be found down below. I hope you all enjoyed that, and I will see you all later. Special thanks to Zenjamin, Squarecrow, Spy Games, Manta Ray, GameMaker, GameArt Indie, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.